Hello students, this is part 2 of integers. In our first part of integer, we have learnt about how the two given integers are added when they have same sign or they have opposite sign. Also, we have solved exercise 1.1 from NCERT based on them. In this part of integer, we will solve exercise 1.2 from NCERT, but before that we will study properties of addition and subtractions of integers. So first of all, we will study properties of addition of integer, then we will study properties of subtraction of integer. So let us start. Our first property of addition of integers is closure property of addition. So closure property of addition states that if a and b are two integers, then a plus b is always an integer. For example, you can see here we have taken two integers 6 and 3. So 6 and 3 are both are integers, and after adding 6 and 3 we get 9, which is also an integer. Again we have 15 and minus 9. So you can see 15 and minus 9 both are integers, and after adding 15 and minus 9 we get 6, which is also an integer. Similarly, minus 3 and minus 11 both are integer, and after adding minus 3 to minus 11 we get minus 14, which is also an integer. Hence we can say that sum of two given integers is always an integer. So the integers are closed under the operation of addition. Next is commutative law of addition. So commutative law of addition states that if a and b are two integers, then a plus b will give the same result as b plus a will have. For example, we have taken here minus 4 and 9, two integers. So you can see first we add minus 4 to 9. So it will give the result of 5. And after that we add 9 to minus 4. Then it again give the same result of 5. So we can say that either we add minus 4 to 9 or we add 9 to minus 4, we have the same result. Another example is minus 5 and minus 11. So you can see minus 5 and minus 11 both are integers. So in this case, first we add minus 5 to minus 11. So it will give the result of minus 16. And after that we add minus 11 to minus 5. But again it will give the same result of minus 16. So we can say that either minus 5 is added to minus 11 or minus 11 is added to minus 5. Both the case will have the same result. This is the commutative law of addition. Associative law of addition. It means that under the operation of addition, the given integers can be associated in any manner, but it will give the same result. So it can be stated that if a, b and c are any three integers, then if we add a plus b and the resultant of a plus b is added to c, then it will give the same result as when we add a to the resultant of b plus c. It will become more clear from this example. So let us see. Here we have considered minus 6, minus 8 and 5 as three integers. So first we add minus 6 to minus 8, and the resultant of minus 6 to minus 8 will be again added to 5. So let us see. Here we have added minus 6 to minus 8. You know that minus 6 plus minus 8 gives the result of minus 14. Now this result minus 14 is added to 5. So minus 14 plus 5 comes out to be minus 9. Now in the next step what we have to do? We have to add minus 6 to the resultant of minus 8 plus 5. So you can see here minus 6 plus within bracket minus 8 plus 5. It can be written as minus 6 plus, we know that minus 8 plus 5 gives the resultant of minus 3. So minus 6 when added to minus 3, it gives the same result of minus 9. Hence we can say that within bracket minus 6 plus minus 8 plus 5 gives the same result as minus 6 plus within bracket minus 8 plus 5. This is the associative law of addition. Now what is additive identity? So additive identity is such an integer which produces no effect when it is added to a given integer. So we can say that for any integer a, we have a plus 0 is equals to 0 plus a equals to a. So it is clear that either we add a to 0 or we add 0 to a. It gives the same result a. Hence we can say that 0 is such an integer which has no effect on the given integer a. Hence 0 is called additive identity for integers. For example, say we have an integer 6. Then either we add 6 to 0 or 0 to 6. It gives the same result 6. Again, we have chosen an integer minus 7. So either we add minus 7 to 0 or 0 to minus 7. The result will be same, that is minus 7. Hence it is clear that 0 is an additive identity. Now additive inverse. So additive inverse is that integer which when added to a given integer gives the result of 0. So for any integer a, we have a plus minus a equals to minus a plus a equals to 0. So from this expression, that is a plus minus a, you can say that the minus a is opposite of a, and minus a is such an integer which when added to the a, it gives the result of 0. That's why we can say the additive inverse of a is minus a. And from this expression, that is minus a plus a, you can say that a is the opposite of minus a, and a is such an integer which when added to minus a gives the result of 0. Hence we can say that additive inverse of minus a is a. For example, if we have an integer 5, then there exists an integer minus 5 such that when 5 is added to minus 5 or minus 5 is added to 5, we have the result of 0. So from this expression, that is 5 plus minus 5, we can say that minus 5 is the opposite of 5, and it is such an integer which when added to 5 gives the result of 0. So we can say that additive inverse of 5 is minus 5, because minus 5 when added to 5, we have the result of 0. And from this expression, minus 5 plus 5, we can say that 5 is the opposite of minus 5, and 5 is such an integer which when added to minus 5, we have the result of 0. So we can say that additive inverse of minus 5 is 5. Why? Because when 5 is added to minus 5, we have the result of 0. Now we will study properties of subtraction of integers. So first property is closure property for subtraction of integer. So if a and b are any two integers, then a minus b is always an integer. For example, you can see here 2 and 5 both are integers, then 2 minus 5. 2 minus 5 can be written as 2 plus within bracket minus 5, and it gives the result of minus 3, and we know that minus 3 is also an integer. Another example is 6 and minus 9. So you can see that 6 and minus 9 both are integers. So if we take the difference, that is 6 minus minus 9, then it can be written as 6 plus 9, which comes out to be 15, and 15 is also an integer. Hence we can say that the subtraction of any two integers is also an integer. This is the closure property for subtraction. Now subtraction of integers is not commutative. What does it mean? It means that if we have two given integers a and b, then a minus b is not equal to b minus a. That is, we can say that commutative law is not valid for subtraction of integers, because as we change the order of subtraction, the result will differ. It will be more clear from this example. Here we have considered two integers 3 and 5. So you can see when we subtract 5 from 3, that is 3 minus 5, then it can be written as 3 plus within bracket minus 5, and it gives the result of minus 2. Now next step is we have to subtract 3 from 5. Then 5 minus 3 is equals to 5 plus minus 3, which gives the result of 2. So here you can see that it gives the result of 2, and this gives the result of minus 2. So it is clear that a minus b, that is 3 minus 5, is not equals to b minus a, that is 5 minus 3. Hence we can say that commutative law is not followed for subtraction of integers. Again, subtraction of integers is not associative. What does it mean? It means that if we have given three integers a, b and c, then if we subtract the integer c from the resultant of a minus b, then it will not give the same result as if we subtract the resultant of b minus c from a. Hence, we can say that associative law is not valid for subtraction of integer, because under the operation of subtraction, integers cannot be associated in any manner. It will become more clear from this example. Here we have taken three integers 3, minus 4 and minus 5. So let us start. First we will subtract minus 5 from the resultant of 3 minus minus 4. So it can be written as 3 plus 4 minus within bracket minus 5, which is again equal to 7 plus 5, and it gives the result of 12. Now what we do? Now we subtract the resultant of minus 4 minus minus 5 from 3. So it can be written as 3 minus within bracket minus 4 plus 5, which comes out to be 3 minus 1 and have the result of 2. So it is clear that 12 is not equal to 2. So we can say that when we subtract minus 5 from the resultant of 3 minus minus 4 is not equal to when we subtract the resultant of minus 4 minus minus 5 from 3. Hence, subtraction of integers does not follow associative law. Let us solve exercise 1.2, which is based on these properties. So our first question is, in a quiz, team A scored minus 40, 10 and 0, and team B scored 10, 0 and minus 40 in 3 successive rounds. Which team scored more? Can we say that we can add integers in any order? So here we have given 3 successive rounds score of team A and team B, and we have to determine which team scored more. So in order to determine which team scored more, we have to take the sum of all the 3 successive rounds score. So we can write total score by team A is equals to sum of scores in 3 successive rounds, which is given as minus 40, 10 and 0. So it can be equal to sum of minus 40 plus 10 plus 0. Here again you can see that we are adding two integers minus 40 and 10. And minus 40 is a negative integer while 10 is a positive integer. It means we are adding two opposite integers. And when we have to add two opposite integers, we take the difference of their values. That is, we take difference by subtracting 10 from 40, which comes out to be 30. But what will be the sign? The sign will be same as the greater value have. So from 40 and 10, the greater value 40 has negative sign. So our result will also have negative sign, that is minus 30. Now total score by team B is equals to sum of scores in 3 successive rounds, which can be written as 10 plus 0 plus minus 40. And again it gives the same result of minus 30. So we can say that total score by team A is equals to minus 30 and total score by team B is also equals to minus 30. Hence, score of both the team are same, that is minus 30. Again you can see that here first we add minus 40 to 10 and then 0 and gives the result of minus 30. And in this case we add 10 to 0 then minus 40. But again we have the same result of minus 30. Hence we can say that either the orders are changed but the result is same. So we can add integers in any order. Hence we can write yes, we can add integers in any order. Also we know that addition of integers follow associative law. Now our next question is, fill in the blanks to make the following statement true. So our first fill in the blanks is minus 5 plus minus 8 is equals to minus 8 plus blank. So we have to fill this blank. So by commutative law, we know that if there are two integers a and b, then a plus b is equals to b plus a. So if we consider minus 5 as a and minus 8 as b, then we see that a plus b is given, which is equals to minus 8, and we know that minus 8 is b. So b is given but a is missing. So in the place of blank we fill value of a, which is minus 5. Hence our result is minus 5, that can be filled here. In B part, it is given minus 53 plus a blank, which is equals to minus 53. So you can see that in both the side the integers are same, that is here is also minus 53 and here also on the right hand side minus 53. It means in the blank we have to place such an integer which produce no effect on the given integer minus 53, and we know that such an integer is additive identity. So 0 should be placed here. Why? Because when we add 0 to minus 53, it will give the same result, minus 53. Hence our answer is 0. Now in part C, it is given 17 plus a blank and the result is 0. It means in this blank we have to add such an integer which cancel out the given integer 17, and such an integer is known as additive inverse, because we know that if additive inverse of a number is added to the number itself, then the result will be 0. And additive inverse is always the opposite of the given number. It means in this blank the number that should be placed is opposite of 17, and opposite of 17 is minus 17. Hence we place minus 17 in this blank. Now next part is in a closed bracket 13 plus minus 12 is added to a blank, which gives the result of 13 plus within closed bracket minus 12 plus minus 7. So by associative law of addition we have a plus b within closed bracket plus c is equals to a plus within bracket b plus c for any three integers a, b and c. So if we associate a to 13, b to minus 12 and c to minus 7, then on right hand side we see that a is given as 13, b is given as minus 12 and c is given as minus 7. But on left hand side a plus b, that is given 13 plus minus 12, but c is missing. It means that in this blank c should be placed, and the value of c is minus 7. Hence our result is also minus 7. Our next question is, for each of the following statement write true and false. So first statement is the smallest integer is 0. This is a false statement. Why? Because you know that all the negative integers are smaller than 0. So 0 cannot be smallest integer. Second statement is minus 10 is greater than minus 7. This is again false, because we know that as we move from left to right on a number line, the value increases, and when we move from left to right, minus 10 comes first, then minus 7 comes. It means that minus 7 is greater than minus 10. Hence this statement is false. Third statement is 0 is larger than every negative integer. Yes, this statement is true. Again, because we know that on a number line, as we move from left to right, value increases, and 0 is right of all the negative integers. Hence it is larger than every negative integer. Fourth statement is the sum of two negative integers is a negative integer. This is always true. Why? For example, if we have two negative integers minus 5 and minus 3, then if we add these integers, then what we get? Minus 8, which is also a negative integer. Hence we can say that sum of two negative integers is a negative integer. And last statement is the sum of a negative integer and a positive integer is always a positive integer. So this is not true. This is a false statement. For example, if we have two integers, one negative integer minus 17 and other as positive integer plus 10. Then when we add these two, we get minus 7. But in the statement, it is written that we always get a positive integer. So it is false statement. Thank you, students. Rest of the questions of exercise 1.2 from NCERT and also from exercise 1A from RS Agrawal, you have to solve by yourself. Thank you.